Hello everyone. In this video I will discuss the oil source correlations within the Montney Petroleum system in the Western Canada Sedimentary Basin. We will explore the geochemical signatures of Montney-sourced oils and the geospatial distribution of different oil families. This work was supervised by Dr. Zhuaheng Qin and Dennis Jiang of the Geological Survey of Canada and reviewed by Professor Nicholas Harris from the University of Alberta. This presentation is divided into 5 sections. Let's begin with the first part. Montney Formation is one of the most prolific hydrocarbon-producing formations in the Western Canada Sedimentary Basin. It yields gas, natural gas liquids, and oil. Exploration of this formation began in the 1950s, initially targeting shallow, conventional reservoirs in the eastern portion of the play through vertical drilling. Over the last 20 years, technological advances, particularly horizontal drilling and multi-stage hydraulic fracturing, have made the development of tight oil and gas resources in the Montney possible. According to the National Energy Board in 2013, the formation contains an estimated 90,466 million barrels of oil equivalent in marketable, unconventional resources. Previous studies have identified various oil origins. For example, Reediger classified the oils into 2 groups, one sourced from the Doig Formation and the other from the Jurassic-Gordondale member. Edgesy proposed 3 oil families, Family X, Family Y, and Family Z. She interpreted Family X oils as originating from the Doig phosphate, while Families Y and Z were linked to the Jurassic-Gordondale. However, the contribution of Montney-sourced hydrocarbons remains uncertain. Our study focuses specifically on clarifying this aspect. Let's see the second part, 3 different oil families in Montney Petroleum system. In our analysis, we examined 78 oil samples characterizing their geochemical signatures, including saturated and aromatic hydrocarbons, sulfur content, and stable isotope compositions. All data were obtained from the Geological Survey of Canada database. This slide shows the distribution of the samples. Based on saturated hydrocarbon biomarkers, we identified 3 distinct oil families. Family A oils show higher carbon-35 to carbon-34 ratio or carbon-35 homohopane index, which is greater than 1. A dominant carbon-29 hopane peak and a higher carbon-24 tetracyclic terpene to carbon-26 tricyclic terpene ratio. These characteristics suggest a source rock deposited in an anoxic carbonate or evaporitic environment. Family B oils are dominated by hopanes with comparable abundances of carbon-24 tetracyclic and carbon-26 tricyclic terpenes. Family C oils are marked by an abundance of extended tricyclic terpenes from carbon-30 to carbon-44, with almost no hopanes present. The 217 mass fragmentograms reveal that Family A oils are characterized by very low diasterane abundances relative to regular steranes. While Family B and Family C oils display broadly similar sterane distributions, Family B oils are distinguished by a relatively lower concentration of carbon-28 regular steranes compared to Family C. Sulfur and stable carbon isotope also highlight the distinctive characteristics of the 3 oil families. Family A oils exhibit high sulfur, high carbon isotope. Family B oils show moderate sulfur and intermediate carbon isotope, and Family C oils are characterized by low sulfur content and lighter carbon isotope values. Analysis of aromatic hydrocarbons further supports these distinctions. The concentrations of dibenzothiophenene and methyldibenzothiophenene in Family C oils, as well as in Montney condensates, are relatively low. Since both compounds are sulfur-bearing, this is consistent with the low sulfur content observed in Family C oils. Now let's move on to oil source correlation. Geochemical signatures suggest Family A oils show a strong correlation with Jurassic-Gordondale source rock extracts. Family B oils correlate well with extracts from the Doig Formation. Family C oils have often been interpreted as also originating from the Doig Formation. For instance, Allen and Creaney attributed the formation of family C oils to sporadic salinity enhancements during Doig deposition. However, based on our findings, we propose that family C oils are primarily of Montney origin, supported by the following observations. Family C oils show strong similarity in biomarker profiles to Montney source rock extracts. For example, a cross-plot of carbon-24 tetracyclic terpene to carbon-26 tricyclic terpene ratio versus TS to TM ratio clearly demonstrates the affinity of family C oils and Montney extracts. This is another cross-plot, using carbon-23 tricyclic terpene to carbon-30 hopane ratio versus TS to TM ratio. Both the family C oils and Montney extracts cluster within the same region of the plot. Additionally, family A and B oils are not typically observed within the Montney Formation except near the top unconformity. This further suggests that family C oils found deeper within the formation are Montney-sourced rather than migrated from overlying formations. Stable carbon and sulfur isotope values further support the Montney origin of family C oils. For instance, during the final million years of the Permian period, the mass extinction event led to a significant reduction in the global carbon-13 isotope levels. This isotopic signature is mirrored in the carbon isotope values found in family C oils. Similarly, the sulfur isotope trend aligns with this interpretation. In the early Triassic, marine sulfur isotopes exhibit a rapid positive excursion, a feature also observed in family C oils. Another line of evidence is the presence of family C oils within the Doig, Halfway, and Charlie Lake formations, suggesting upward migration from the Montney Formation. These occurrences are consistently located near active Permian faults, which would have facilitated vertical oil migration through fault pathways. This migration process has geochemical consequences. Migration from Montney to overlying strata typically results in a decrease in the toluene/benzene ratio and an increase in the saturated/aromatic hydrocarbon fraction ratio. This pattern is evident in family C oils found in the Doig, Halfway, and Charlie Lake formations. Additionally, oil migration tends to reduce the abundance of high molecular weight hydrocarbon components, which is observed in family C oils in the Halfway and Charlie Lake formations. Some family C oils have even been discovered in Permian-aged reservoirs. Given the thickness of the Montney Formation and the relatively small fault displacements in these areas, it is unlikely that these oils originated from the overlying Doig Formation and migrated downward. Moreover, lateral migration from the deep basin is improbable, as source rocks in that region are thermally mature and primarily generate gas, not oil. Let's now explore the spatial distribution of the three oil families. Based on oil source correlations, family A oils are mainly distributed in the northeastern part of the basin, near the Montney subcrop edge, where Doig and Charlie Lake formations are absent, and the Montney reservoir is directly overlain by the Gordondale source rock. Family B oils are found near the Doig Formation subcrop edge, where hydrocarbons migrated through Triassic strata along updip paths toward the northeast. Family C oils are predominantly located in the deep basin, where high total organic carbon intervals were deposited within the Montney Formation. This schematic cross-section illustrates the potential spatial accumulation of the different oil families. Montney-sourced hydrocarbons can migrate upward and accumulate in the Doig, Halfway, and Charlie Lake formations, facilitated by faults and regional unconformities. Final summary. To conclude, three distinct oil families, Family A, Family B, and Family C have been identified within the Triassic oil accumulations of the Western Canada Sedimentary Basin, each characterized by unique geochemical signatures. Family A oils are geochemically linked to the calcareous Jurassic Gordondale member. Family B oils are interpreted to be sourced from the Doig Formation. Family C oils exhibit strong geochemical similarities to extracts from organic-rich Montney shales and are believed to originate from the Montney Formation. In terms of spatial distribution, Family A oils are primarily found near the Montney subrock edge where the Jurassic Gordondale member lies directly above the Montney Formation. Family B oils are located near the Doig Formation subcrop edge, consistent with updip migration patterns. Family C oils are predominantly distributed in the Deep Basin, coinciding with the depositional centers of high TOC Montney intervals. Thanks for watching. If you found this video helpful, please like, comment, subscribe, and share this channel. Thank you.